Thanks, guys. Thanks for your thanks for attending my workshop here. Just to make it different to the other talks, you know, it's open for questions anytime. So if you got any queries or anything that you would like to ask about, just ask. There's no need to wait for the to the end. Right, so that's the title of my presentation. It's Cybersecurity for Industrial Control and Automation Systems. Right, and this is the list of the topics that I'm going to cover. So I will introduce the problem there, and then we'll move on to talk about the applications for industrial control systems. What could be the security threats for those systems, the security process, and then we'll focus on one aspect of the security process. That's the penetration testing, including the test bed, the experimental work, the penetration testing experiments, the evaluation, and then we'll end up with the conclusion. I've got so many slides there, so some of them might not be useful much, so I'll just skip through, or we'll just highlight them only. So basically, when it comes into the control systems, nowadays most of those systems they are computer controlled, and often they are connected to the corporate networks. So when we talk about systems or control systems, they are meant to process certain, to control certain processes within the whole plant or the whole manufacturer. So having the control systems connected to the corporate network, so to manage the processes within the plant or within the manufacturing plant, makes them vulnerable to different types of threats and attacks. Why is that? Because if the industrial network is connected to the corporate network, that means the whole network is connected to the internet. And if a particular plant or a particular manufacturer have got their processes somehow connected to the internet, that would make them really vulnerable to various threats. So examples of those threats could be energy and power generation failures, control systems malfunction, and maybe different sorts of incidents or hazards incidents. It was in 2010, the BBC talked about a particular malware or a virus that was called Stuxnet. And this particular malware actually was specially designed to attack the Iranian nuclear power system over there. And the media talked about that particular malware and how dangerous it was and so on. And looking at the way that this particular virus was designed, it's really complicated. It's not a kind of virus that is designed by just having a number of hackers met together so to develop such a virus. It was really complicated. So what they are saying there is that such a virus it has to be state-sponsored. Otherwise, they can't really, you can't rely on just one team of people to design such a dangerous virus. So you would be able to guess which country maybe is interested in designing such an interesting virus. It could be, yes. You never know. Right. Okay. So that's one of the. So when I talk about control systems for industries, I'm referring to critical industries. Okay. Those industries. They are nature critical. So, for example, here it is one organization is called CERT. And this organization is responsible for They conducted a survey. It was last year, and they reported 256 incidents. They looked at a number of critical industries. So what they noticed is that the energy sector or industries that are operating in the energy sector, they've got the highest number of incidents or attacks, basically, on their infrastructure. Other critical industries, such as the critical manufacturing, they've got about 20% of the incidents reported. Yeah, go on.
Yeah. What do you mean by critical manufacturing?
Okay.
Plants or?
Well, any industries that they produce critical products. Could be pharmaceutical, or it could be any military-related
Okay.
products, that kind of nature. Any critical products, basically. And there are other industries which were having less incidents reported as well. So this diagram here indicates that there are certain issues, or there are issues with the security when it comes into those critical industries. Right. So just before we get into the details here, let me just highlight some of the applications for industrial control systems. These are just some examples of what could be critical infrastructure. So there is the medical sector there. The other example here for water storage, nuclear power station, energy grid, petrochemical plant. So these are just examples. Now, as you can see here, most of those industries are becoming connected to the internet. Why? It is part of the management approach is to have remote access to those systems. So that would allow the corporate networks, which are part of the internet, to monitor their industries. Okay, so to allow management to have control of how their industries are operating. Okay, and also to allow their engineers to have like a remote access to their systems as well. That's why they have to get connected to the internet. There's also, you probably heard with, doctors, performing medical operations online or through the internet. So specialists nowadays, they don't need to be, connected directly with their patients. They can, perform their operations while they are away from their patients. So, and that made those industries vulnerable to different attacks and so on. And it is just because of the nature of those industries, the control systems are meant to control certain devices, for those industries, such as the sensors. If it is a petrochemical plant, for example, you have the sensors that take or get readings about the temperature, about the pressure for certain processes or certain operations, send them to the plant in order to control certain processes. So that's why they need to have their own networks, so to pass that information from one place to the other within the plant itself. So that's one application. This is just an example here to show you what could be a particular industry here, or a basic system for a petrochemical plant. So here you have the control room, for example. Here you have your the RTUs, or the remote terminal units that are connected with the sensors. The purpose of the sensors, as I said, is to get the temperature readings, to get pressure readings, and so on. Pass that information through the front-end processors to the control room. Okay, so that would allow the management here as part of as part of the control room is to get those readings and to be aware of how the plant is performing. Okay, and then to send instructions through the network back to the to the front end processor where you have the PLCs, the programmable logic controllers that can instruct the RTUs to change the temperature in case that it goes up to a certain level, or maybe to switch on a cooler in case that the temperature goes beyond a particular level. So that's the purpose of that system. So as you can see here, there is this in what we call ICS network, or industrial control system network. So you have the wireless link, you have the routers that pass the instructions and the information, and here you can have the database where all the data related to the processes, related to the readings, can be stored there. And then what you have, that's the corporate network, where the management network and the administration and everything. So you see that there is a connection there with the industrial network through the firewall there, and then you have the internet. So this is just one example to show you how industrial networks are becoming connected to the internet through their corporate networks. Right. So what could be the threats then? Well, before we get into the threats, here I'm trying to highlight what could be the vulnerabilities, because the vulnerabilities lead to the security threats. So examples of vulnerabilities is that when you have a poor design for the communication links that link the plant to the control room, for example. Poor configuration for the firewalls as well as the databases, lack of authentication mechanisms, so that the instructions can if there is no clear authentication systems or proper authentication system, that could lead to having anybody to give instructions to the system to do certain operations or do certain processes. Nowadays, industrial networks or industrial systems or plants, they have their systems connected to their partners, okay? Especially, for manufacturing, for example, they need to have like connections for their supply chain, so to know how the products are moving from one place to the other, from one manufacturer to the other, and so on. So that means the manufacturers, they have their networks connected to their partners' networks as well. So making your network connected to somebody else's network, so if their network is not properly protected, that makes your network vulnerable to attacks as well. So what could be the threats? These are just some examples here. It could lead, the kind of threats could be production disturbance, blocking access to the production lines, for example. Some threats could be life-threatening. If the attackers can get to the HMI, the human-machine interface, then they can actually monitor all the processes. They can take readings about certain metrics temperature, pressure, and so on and so forth. So if it is a nuclear power station, that kind of information is really sensitive to get, to allow somebody to get into that kind of information. So if you allow them to get into that level or to get access to your network or HMI, then they can actually change those values or probably change those settings. So that could lead to a major problem. Or they can send false commands to the main reactor within the nuclear power station, and you would imagine what can such a problem could lead to. So so back to the same diagram here. So the problems could be, weak firewall rules. So if you have a firewall there that is meant to protect the industrial network, if you don't have strong firewall rules, that could lead to problems. So one problem, unauthorized access to the database there. So that database could be would be vulnerable to unauthorized access. The databases within industrial control systems is really important part. It's a crucial part of the network because it is there where the critical values for your processes are stored. And if anybody can get into that kind of data, then they can figure out what processes that are operating within your plant. And if they can get such information, then they can figure out how to access those processes and control them. Another problem could be insecure wireless links. So the link there, which uses a wireless link, if it is insecured, then even with a laptop, that could allow somebody to come and listen to all the communications that are taking place at that link. So and then that would give them information about what kind of data that is passing through, what kind of instructions that are sent from the control room to the PLC and then to the control systems there, or the RTUs, the remote terminal units. So that could be an issue there. And the tools that are that can allow others to listen to wireless communications, unfortunately, they are available online, which people can make use of. So insecure wireless link could lead to unauthorized access to the control room over there, and then to control the SCADA system. That could be one problem. Another problem is to have unauthorized access to the front-end processor there, which controls the operations here, through the PLCs and the sensors, as well as the RTUs. And then if somebody gets into the PLCs, then they will be able to take control of the processes there, which could lead to changing or disrupting any chemical operations. Just one example there. So that could be a threat as well. So these are just some examples of what could be the problem there. Now, how attackers get into that level of getting information related to processes, operations within a critical industry? They use reconnaissance as a main service to get into to such important data. And unfortunately, there are so many tools that are available on the internet. It's not only the tools. Actually, Google itself is supported with certain features that allow attackers to do the reconnaissance itself. So it is possible to do that. With Google, it's possible to get information related to the communication protocols that are used for the communication between the control rooms as well as the end devices and systems. It is possible to use Google to get data that is even stored in the database. So that could be the problem. This is one example here of using what is known as the Google hack tools. They are also called Google Docs. This is one example here, which is the file type operator. It is used here to actually get into passwords that are stored in a database. Here I just tried to cover the IP numbers of the computers that are used to store the database. Okay. Here is another example. This is another version of the file type operator, which actually gets the IP addresses are there for a number of computers together. So it can target a network, not just a single computer. This is another example here for another Google Doc or Google hack feature. It's called the EXT there. And here it is used to get into what's supposed to be an encryption key, a complicated encryption key. It is in clear text there. This is another example. This example is published by somebody else here. That's the source. Here it shows with the use of Google nowadays, you can actually get into certain RTU devices, the remote terminal units themselves, and see what they are used for. Here it seems that it is used for a water plant. And even you can get information about the pumps used and how many of them and their specs as well. Okay, this is Google. It's not only about information, you know. It is also about sensitive information that is related to devices that are supposed to protect and do various operations. Right, this is another example here. This is using Google as well. It gets into systems where you can get information related to the temperature that monitor the computers rack. There is a rack of computers, and you can get information related to the humidity, temperature, and other devices as well. And you can also see what are the limits of the temperature there, the operating temperature for those devices. So this kind of information is really sensitive because such information is not supposed to be open to anybody else or anybody just to, you know, with the use of Google, they can get into that level of information. Right, there is another tool here that is called Shodan. It is available online as well, and the tool here is used to get details about the protocol that is used for industrial networks. It's called Modbus. It's a well-known protocol that is used to send data from the RTUs, the devices, the sensors, to the control rooms. So it's a well-known protocol, and it's used to, you know, Shodan tool is used to get that kind of information as well. So all these examples are there just to show you how it's possible to perform reconnaissance kind of operations with the use of Google and other online resources. So now let us talk about the process, the security. Now, in order to protect those industrial networks, there is a security process there. And it has got four main stages. The first stage is about the assets identification. So for any owner of any industrial network, they need to identify exactly where are their main assets, the main operations and so on. They need to perform risk assessment for their processes and assets, followed by defenses implementation, and then finally system monitoring. So they have to keep monitoring their systems continuously. And then, it's a cycle, so that it has to be done that way. So for my presentation, what I'm going to do is to focus. I presume that I've got enough time, to get into the details of the risk assessment there. Yeah. Right, okay, great. So my focus is just at this stage here, which is the risk assessment. This is what I'm going to focus on, and this is the experiment that we carried out for our research. So risk assessment, two stages. You have the vulnerability assessment and the penetration testing. The vulnerability assessment is just to use Google Hack, for example, to do some vulnerability checking and reconnaissance checking and so on and so forth, to identify if there are any vulnerabilities within a particular system, and then followed by penetration testing. Penetration testing is it is the second stage of the risk assessment to do some hacking to the system, and then to see if it is possible to perform successful attacks, and then build on that. So that's the way how it works. So my focus for the rest of the for the rest of the presentation is on this stage. So I'm not going to talk about the defenses implementation. This is a different topic there. So the focus is just on the penetration testing, right? Okay. Now penetration testing. It is becoming a well-defined process where the owners of the manufacturers, or the industrial operation, they can do penetration testing as part of the assessment for their systems. So to see if there are any problems, any limitations, any security holes within their systems. Okay. In order to perform penetration testing, the penetration testing person should have the attacker's mindset. Okay, it's really important to have the attacker's mindset in order to perform penetration testing. It's like what people call ethical hacking. Okay, probably heard with such term. Ethical hacking. It's about performing. Companies recruit hackers to check to hack their networks, to test if there are any security issues within their networks. Okay, it's not only companies. Nowadays, government-related agencies and government-related organizations, they recruit hackers in order to test their the security of their systems and organizations and so on. So it's becoming like a standard process. So the tester need to have that mindset of the attackers. Second is to exploit any vulnerabilities, and finally to test any defense mechanisms within the system that they are testing. Okay, right. Now there are three different types of penetration testing. There is what they call it the black box one, where the tester, the person who's going to test the system, is not or shouldn't be given any information about the system. So they do the test without knowing, what defense mechanisms that are available to the system, right? There is another one called white box testing, where the tester is given all the details, the design drawings and all the details of the network, how they are designed, and everything, right? And there is the gray box testing, where the tester is only given part of the information, okay, about the system, so that they are not given everything. which is often is the best approach to do. Why? Because if you don't give any information to the tester, maybe they won't be able to figure out some of the main details, so they won't be able to perform proper testing for their network or their system. And if you give them all the information, then obviously that's not going to be useful as well, because then it's not going to be really a test, because hackers are not supposed to have any information about the network that they are testing. So gray box testing is the right approach. Just give them certain information to help them to do the job properly and finish it within time.
I got a point there.
Yeah, go on.
When there's partial or full disclosure, is any of it ever deliberately false?
Mm-hmm.
That's what I thought. In other words, you tell them something's going to do something, and
Right.
You go ahead and tell them, and it turns out it's not even true, and they're supposed to find they would be supposed to find that and tell you what is the truth. Then I would say, is that a true statement?
More or less,
Okay.
yes. It is about telling them certain information so to help them to do the job properly, and obviously to report back any details or any outcomes that they get out of that test. That's for sure. It is about telling them the critical operations that are happening within your environment, so that if it is a critical environment, say it's a nuclear power station, okay, and you want penetration testers to test your station, the power station there. Obviously, you need to tell them that there are certain operations you don't want. You don't want to get those operations disturbed by the test, because if they are disturbed, then that affect the whole station or could lead to a problem. So you would like to give them certain information so that they can do the job without disturbing the business of the environment.
Understand.
Yeah. Right. Okay. So penetration testing has got its own life cycle there. So it starts with the reconnaissance stage, which is about information gathering. So the tester needs to collect as much information as possible about the environment, the processes that are operating within the system there. They can use Google Hack, to do reconnaissance, or they can use other tools. There are well-known tools. There is nowadays everybody, or the majority of organizations, they use a tool called Kali, K-L-I. It has got so many interesting tools, for hacking and doing all the reconnaissance operations. It is freely available, and the free version, it is available, but it has got certain limitations. So you cannot use the free version, to do reconnaissance for large corporations or large industries. And then the second stage, once the information is gathered, then you move on to the second stage, which is the vulnerability scanning, where you scan the target for any particular vulnerability, or to identify, where vulnerabilities are within the system there. The third stage is the exploitations, which is about performing the attack. Okay, and then finally reporting. So to get the report done and to show all the results of the test, including any recommendations that are useful for the organization. Right, so what we did actually for our case, in order to try this, we started this, after the 2010, when we heard about that Stuxnet virus and so on. So we thought it would be interesting to learn about industrial networks, how they are protected, and how to perform penetration testing. Because previously my work was more about penetration testing related to just corporate networks, just computer networks. Only recently, when we started, where we heard about the news that critical industries are having problems with their security, and there are viruses that are designed mainly to attack those critical industries, then our research started to shift towards that direction. Okay, so recently, it was only a few months ago, we started. It's an ongoing research actually. So we just started this research a few months ago. And we started developing, a basic test bed, so to allow us to learn more about the details of how to perform penetration testing for industrial networks. Because previously we used to do it for just corporate networks, the computer networks without any industrial operations. So in order to do that, for us, I'm working for a university, so we don't have the budget, to develop such plans and so on. So the only option is to have a virtual environment. Okay, so that's the positive thing about virtualization, is that you can do a lot of experiments with the use of virtualization. Okay, so what we did, we developed a virtual network there that to model an industrial network, ICS network, Industrial Control Systems Network, where one computer there controls a particular industrial operation, okay? And the operation that we selected is a PLC-controlled paint mixer. So it's a paint manufacturer there where you mix multiple colors and so on to produce other paint colors, basically. That's the operation there, and other few machines there. All these machines now, as a virtual environment, you can have them actually in just a single computer. Okay, single powerful computer with minimum, you need at least minimum 8 gigabyte RAM with the high-speed processor. It is possible to have 3 machines. If you need 4 machines, probably you need to have more powerful computer. And the virtual environment that we used is VirtualBox. The 2 major virtual environments that are currently available, there's the VirtualBox or VMware, where you can develop basically any virtual experiments. That's VirtualBox, yes, exactly, yeah, Oracle. It is supported by Oracle, yes. So that's the test bed. Now the target machine is this one here, the one with IP address, the one that ends with .0.8. So the example that I'm going to elaborate on is this one here. That's the target machine, 0.8. Right. Now, obviously, to model such an operation, we need to use a software that can help us to do this. And the only option, obviously, well, the best option is MATLAB, as discussed by Jim. It's a useful software where you can model almost anything actually nowadays with MATLAB. So the way it works is that, okay, because our knowledge about MATLAB, because for us cybersecurity, that's our research. We know about cybersecurity networks and so on. Our knowledge is quite limited about MATLAB because we don't use it for that purposes. So what we did, we tried to find a partner that can help us to do our experiment. So we managed to find a good partner that is Schneider Electric. It's a well-known company within the industry. So they are very active in the Far East area. So their branch in Indonesia, actually, they've got a model, the model that we used, which is the paint mixer. Okay, so they have that model there. We used it. I don't need to get into the details of the model here. It's just it talks about different tanks there with different colors. You have the mixer somewhere there, and then you have the paint tank there, and that's the diagram that shows the tank when it is filled in, and then with different colors depending on the mixture that you have here. So it's just a to have an operation, a process there for us. And this is their lab. This is the lab that belongs to Schneider Electric in Indonesia. That's their test bed. As you can see here, that they've got different. When they run the simulation, they have different colors there as well. We don't have that part here, so we have only this model there and MATLAB, which is very kind of them because they just gave us the model, even though we told them that we are going to hack it and do some problems to it. But they were, helpful in that terms. They said, okay, which is good. Right. Okay. So that's their model. So what's then? We've got the model. We've got the environment ready. So we are ready to perform our experiments. So what we need to do, we had to. We could have gone directly to that stage, the exploitation, but we thought it's better to follow the whole process, because we are a university, academics, we better follow, procedures and rules and so on and so forth. So we started with the reconnaissance process there. So we used a tool called Nmap. Nmap is a useful reconnaissance tool. It is part of Calais, where actually you can use Nmap to get information. You identify the target or the network target there, the IP addresses for all the computers, for all your computers. So you can identify a range, and it does actually, it scans the whole range of computers altogether. In our case, because the network is already within a virtual environment, so it's not really complicated. So Nmap is able to perform that scan there to do reconnaissance, to tell us the details of every machine there and whether the machine is on or off. This is quite important because for attackers to get into any particular computer, they need to know whether the computer is on or off first. So that's part of the reconnaissance process. And that's the output as well there. It tells you which ports that are on, which ones are off, and so on. And then moving on to the second stage, that's the vulnerability scanning. We use a different tool. It's also part of Calais. It's called Nasser there. So it is a tool that is useful to identify any vulnerabilities within the system. In our case, it is the model that we have. Because it is computer controlled, so we would like to know the vulnerabilities within the computer that is running the model there. Okay, so we use that, and because the model is running on a Windows Server 2008 server, so with the use of Nasser, we were able to identify some of the vulnerabilities there. 67% of the vulnerabilities were critical, and 33% were medium. Yeah. Right. So we realized that there are vulnerabilities within the server there that is running MATLAB, and MATLAB is having the model there, and then we try to identify two critical vulnerabilities. And one of them is Windows related there, which is SMB2. Then once the vulnerabilities are identified, we moved on to the third stage, which is the exploitation. And then we used Metasploit tool. It is also part of Calais. And we can identify exactly what exploit there. That is the SMB2. and then we use this particular code that is related to SMB v2, which is MS 09050. It's very detailed, so I don't need to get into that level. So that's basically the critical operation that is operating there, which is identified here. There, yeah. And then we use Metasploit as well to, we use the use command as well as the show commands. These commands are part of the exploit model to get information about the target. That's the target, the R host. Okay, that's the target computer that is running our model there, the MATLAB model. And then once the target is identified, we should be able to use as part of the attack or the exploitation is to use the payload, and the payload would help us to not only to identify the target, but also once the target is identified, and then you need to identify the controller, the attacking machine. That's the other one, the L host there. That's the attacking machine, so that the target becomes controlled not by their user, but by the attacker's machine. Okay, that's the L host there. And then once those machines are identified, with the use of the commands, the relevant commands there, yeah, and then the attacker's machine will control the victim machine or the target using the TCP protocol and uses port number 4444 there. Right. And once we managed to take control of MATLAB and the operations and the computer itself that controls all the operations, we launched the attack within 180 seconds. So we were able to control the other machine and then stop the machine from running its processes, the ones that are intended for the paint mixer there. And we got this the blue screen, which you are aware of. When you have problem with your Windows, this is what you get there. Right. So it was a successful attack for MATLAB. We haven't reported this yet to the electric or Schneider Electric yet, but they will be happy anyway, so that shouldn't be an issue there. Now, what we are trying to do next, okay, so when we attacked the system, the computer itself stopped the model from running, and obviously no more paint went to the tank there. So the tank is now just empty. It's not processing anymore. Right. We tried to perform other attacks, such as we tried to employ a virus to MATLAB, to the computer that is running MATLAB there. We tried another attack using backdoor there to get into to the computer itself. We noticed that there are different timing, for performing different attacks. Some of, the backdoor attack was really fast there in comparison to the payload, which took 180 seconds. The positive thing about the Calais tool is that it tells you in advance, before you launch the attack, it tells you how much, approximately how much would it take to take control of that machine, the victim machine there. And this is about the CPU usage, the use of memory there as well. You can get all other information. So that basically ends my presentation. And just to conclude that, there are so many, unfortunately, there are so many control systems that control critical operations. They are now still available, connected to the internet, and they are not really protected. The impact of such attacks could be devastating for their operations. And in order to minimize such problems, that the owners of such businesses and industries, they have to seek standard operations such as penetration testing, life cycle, in order to protect their systems and networks. And thanks for your attention.